So how was your weekend? Great. How was your long weekend?
It was a good weekend. How was yours?
Great, great, great. Did you do anything special?
No, I'm still in the process of moving. Today was my last day. Now I gotta organize.
You moved to a different house,
Apartment.
apartment?
Yeah.
Is it rental or you purchase?
It's rental for now.
Oh, okay. That's a good thing. You know, it's a lot of work. Moving to a different place is a lot of work. Yeah. And then that's when you realize how many things that you don't need you have. Right?
Yep.
Yeah, that's very typical. All right, guys, let's it's very weird that Anand is not here. Usually Anand it's the first person to log in. Okay. So today we're going to continue with the module 8, which is class design. And we're going to talk about two concepts that we need to see in this module. One of them is static methods, and the other one is polymorphism, which is one of the four pillars of object-oriented programming. All right. So I'm gonna start with with the same classes as before, and I like to write them, just to remember them. So I'm gonna call this guy static methods. Let me see something here. NDC, yeah, NDC here, and I'm gonna call it static methods. Okay. Okay. Okay, so in this one, I'm gonna create a class called animal. We're gonna use the same concept as before. Okay, gonna call it class animal, and then the animal, it's going to become an abstract class, okay? Just like we did before. Okay, abstract class, and then we're going to have a private integer h and a private string name, right? Now I'm going to have a constructor, right? Let's keep it this way. And I'm going to have another constructor, member overloading, constructor overloading. So we're going to use the same name of the constructor, which is the name of the class, right? But this time we're going to pass an h, right? And we're going to say sys out animal. Okay. And I'm going to say this h, just like we did before, like this. Okay. The animal class is going to have a getter and setter for both properties. So I'm going to create that. I'm going to generate the getters and the setter of the two properties. Okay. Okay. So I have the two getters and the two setters for both properties. Okay. Also, we're going to have a public method that returns nothing or will eat, right? And this one is going to have a print that says animal is eating. Okay. Right? It's going to have another public method that returns a double, right? And it's going to be called get average weight. Okay. We're not going to pass anything. We're just returning 10.0. All right. It's going to have a protected abstract method, right? That returns nothing, right? And the name is print name. Remember that abstract methods don't have a body, okay? They have to be implemented in the class that extends this class, okay? We're gonna have another public method that returns nothing, and the name is print details, okay? We don't pass any arguments, and then we're gonna say, we call the method print name, right here. We call this method, and then we say this out age equals, and then we just use the variable age, okay? Now, we're going to have another method, but this time it's not gonna be protected, it's gonna be public. It's an abstract method, and the name is gonna return an integer, and the name is getWeight, right? And there's no implementation here, right? It's just doesn't have a body, right? That will be the animal class. Okay. Now we're gonna have a class, right? And the class that we're gonna have now is a class named bear, just like the other day. All right, bear, right? So this bear will extend animal. Right? And it also implements the omnivore interface. But I don't have that yet. So I'm gonna go ahead and create it. All right. This is not the one. I'm not using the interfaces one. I'm using the one from the static method package. Okay, not a problem. So I'm gonna create the interface here. I'm gonna call it omnivore. Okay. Omnivore interface. So the omnivore interface will extend two other interfaces. The herbivore, but I will not do it now. First, I will create the interface herbivore. Otherwise, we get confused with the other interfaces that I created before. So I'm going to create the interface herbivore, right? And the interface carnivore. Okay. Now, omnivore can extend, herbivore from static methods and carnivore from static methods. Okay. Okay. Good. That's right. So now we're gonna work on the herbivore interface. The herbivore interface has a default method. And don't forget the default methods, they have a body. Okay. Doesn't return anything, and it's called eat plants. Okay. And then we say this out, eating plants. Perfect. So that would be the herbivore interface. Now we have the carnivore interface that is very similar. Okay, it's very similar. It's just to have another method called eat meat, right? Still default method that returns nothing, right? It's a void return type. And now we can say this out, eating meat, right? Okay, this is an interface. I don't know why I choose class. Right? Good. So omnivore stands herbivore and carnivore. Herbivore is right here. Carnivore is right here. So now we have to work on the class bear, right? And this omnivore that is going to extend is the omnivore from static, right? From a static method, this one. Okay, perfect. Now we have the class bear here. In the class bear, right, we're going to override the method eat plants. Okay, so we have here eat plant. Okay, we're going to override the method. And we're going to say sysout and the bear eating plants. Okay, this comes from the herbivore interface, and here says eating plants. We're just overriding this method, changing the content of the method here, and we're writing bear eating plants. Okay, we're going to also override the method from the carnivore interface, right? Right here, eat meat, right? And then we're going to say sysout, and this one is going to say bear eating meat, right? So okay, so far so good. Now we're going to override the two methods from the class animal, which is print name and get weight. If you take a look at this, we have print name and get weight. We have to implement those methods here. Okay, remember we are extending animal and we're implementing omnivore. But don't forget that omnivore extends herbivore and carnivore. So we have to implement both methods in both the herbivore, eat plants, and carnivore. We just overriding them. We're not implementing, we're overriding them. Okay. Implementation is from abstract classes. So now we have to say get weight, right? And then we overriding that, right? But this one is, I mean, if you do this, if you just comment this out, you get no error because these guys are not mandatory. But these guys are, because they are abstract methods that are not implemented in the animal class. They have to be implemented in the class that extends the animal class, in this class bear, right? So we're going to return this. We're going to return 2000, right? And then we're going to implement print name, right? And now the error disappears. I don't have any more errors here, okay? Now we're going to say sysout bear. That's the name of the animal, right? Now, like I said before, if I comment this out, still works because I'm not obligated to write these methods here. We just overrided them. That's why we're doing that, right? That's why we're including them in this class, because we are overriding them. We're just putting different content in the method, okay? So that's all for, go ahead.
Question, can you change the print name to something else? Bear's name is something.
Overriding is the same name.
No. The in quotes. So when you print, I know where is it coming from.
What you mean change here?
Can you change? No, not there. In the quotes, double quotes. Yeah, just put Smokey the Bear.
Another thing, anything?
Yeah, just type Smokey the Bear. No, Smokey the Bear.
Smokey, like this?
The bear.
Okay, that's okay.
Here you go.
Okay, you wanted to put this? Okay, not a problem. Yeah, I couldn't do with the flowers, but now I can do it here. Remember, you asked me to.
Listen, I'm working on my flower project.
Nice. Okay, so we have another class named bird. Like in one of the movies, I think it was the movie from Iron Man number 3, there was a bad guy who was from Russia, and he said, "Where's my bird?" No, he said, "Where's my board? Where's my board?" Because you know the Russian accent is very strong when they speak in English.
Very familiar.
Yeah. Who's this?
It's Eastern European Evgeny Romenko.
Okay. Okay. Yeah, he said, "Where's my board?" Yeah. All right. So here we have the class bird, which doesn't extend or implement any interface, extend any class or implement any interface. We're gonna say have a method here, and it's gonna be a public method, and it's gonna return nothing. It's just a void return type. We're gonna call fly, right? And then it's gonna say sys out bird is flying. Okay. And we're gonna have another method called eat, right? That returns nothing as well. And it has an amount. It's just passing an amount, right? And we can say bird is eating space the amount value, right? And then with the space units of food. Okay, so this is the bird class, right? Now let's create another interface. This interface is going to be can run, right? And this interface doesn't extend any other interface. We're just going to have a void run method, and then we just pass speed, right? Okay. So now we're going to have a cat class, okay? Cat class. The cat class is going to extend animal, extends animal, and it implements another interface, which is run, okay? And I'm going to create the run interface now, okay? So the interface is run, and this interface will extend another interface, which is walk. So I'm going to create the interface walk. Right. Now run will extend walk. Okay. Right. So let me work in the walk interface that has a default method that returns an integer, and the name is getSpeed, right? And we'll return number 5. That's the speed. Okay. So the run interface will just extend that interface walk. Okay. So let me go back to the cat class, right? And this one will implement run, okay? And now we can work here. So we're gonna have first the constructor. We're gonna pass the age. And then we call the super class with the age, okay? And the super class is the class animal, because the class animal has one constructor that has an age. So we're calling this constructor, okay? It's right here. Super refers to the superclass, the class that this class is extending, okay? Now we're going to override the getWeight method that comes from the class animal, right? Right here. and it has to be implemented in the cat class, right? Now we're going to return 5 here as well, right? And now I'm going to also implement the print name. Where is it? Print name method. Remember, every class that extends the animal class, has to implement these 2 methods because these are abstract methods. If you remember, they're abstract methods. Okay, so they have to be implemented in any class that extends the class animal. Okay, so here I'm not going to put anything. Right, so I'm going to leave it this way. Okay, so I'm done with the class cat. Now I'm going to have a class dog, right? Class dog, right? So this class will extend animal as well, right? But it will implement 2 interfaces. One of them is can run, right? That I already created. And the other one's going to be has tail. So I have to create that interface, right? Has tail. Interface, has tail. So the has tail interface is going to have an integer named default tail length. Don't forget that the variables, the fields in an interface, they're final, they're public, final, and abstract. Okay, they're final. So you cannot change the value, right? And also it has one method that returns an integer, and the name is getTail length. Okay. GetTail length, right? That's it. This is the interface hasTail. We're going to implement that interface, right? hasTail. Okay, good. So now we have to go back to the dog class. We have to implement, right? Eat, get average weight, right? And we also have to implement get tail length, right? But the first thing that we have to do is create the constructor, because that has to be in any class that extends animal, right? Because we're passing the age. So we have to have a constructor. Now we have to call the super, just like we did in the cat class, okay? And I'm gonna print something as well. I'm gonna say, is this out? Dog, okay? Just to identify this class. I'm going to override getTail, right? And this is coming from the hasTail interface, right? Right here. And I'm going to return 5 as well. I'm also going to override eat, right? And here I'm going to say, this out, dog eating, right? And here I'm going to say public double, which is get average. And we're going to return that plus 20. Okay, that's going to be the average weight plus 20. Okay. Now we're still having an issue here. It says the class dog must either be declared abstract or implement abstract method print name in animal. We don't have print name here. So if you don't want to implement print name, just like this, then you will have to make this class an abstract class. And problem solved. Okay, so that gives you the ability to not implement print name and get weight, okay? Because those are mandatory if your class extends animal. They're mandatory. But if you make the class abstract, you don't have to implement it. It's optional. All right. Now we have those classes. We continue. Now we're going to have the class. See here. Can run, cat, dog, eagle. Now we have to create the class eagle. And in the class eagle, we're going to extend bird. Bird, right? Good. Now bird has one method called fly, right? I'm not going to override it. I'm going to overload it, right? That's why I'm going to put here a value, not a value parameter, because in the class bird, this method doesn't have any parameters, okay? So we're just overloading the method. We're not overriding it. Overriding is just to change the content of the method. Overload it, you can change either the parameters that the method takes or the return type, right? So in this case, we're just changing the parameter, okay? And now I'm going to change this and say this out, right? Eagle is flying at height, space, meters, right? Perfect. And then as this returns, or actually it does return this. As it returns this, we have to have a return statement because we are returning an integer, right? Remember that you have a return type here, then you have to have a return statement, right? So class eagle is done. Now we have to create an interface named hop, right? So we're gonna call it hop, right? Now hop doesn't extend any other interface. It just have a static. This is when static comes in, you know, static method that returns an integer and say get average jump height, okay? And then as it returns an integer, we're gonna say return to, right? So this is a static method, okay? And we will understand what static does when we get there, okay? Now we have a class named Husky. You know, Husky is a famous class already, okay? It's always there when it comes to a dog, right? So we have the class Husky. And Husky extends, guess what class? The dog class, right? Of course, remember that this is not an abstract class, so I have to implement print name and get weight. So those methods, they have to be there, right? Unless I make the class Husky abstract, and then I don't have to implement them. So the first thing that I have to have is just have the constructor, right? And we're passing an age, right? And then when we do this, so we have to call the constructor of the superclass that takes an integer. And then we can say sysout Husky, just to identify this class, right? Now we're going to override the method eat. This is a method that is in the animal class. But remember, dog stands animal and Husky stands dog. So that method can be overridden here. Okay? So
did you leave dog abstract or did you?
Dog is abstract.
Dog is abstract, right?
That's right. Dog is abstract. So Husky is not abstract. That's why we have to implement later print name and get weight from the animal class. Print name and get weight. The only reason why I don't have that in the dog class is because I declared the dog cat class abstract. So I'm not forced to do that. If I remove the abstract word, then it gives me an error and tells me your dog must be either declared abstract or implement abstract method print name. But it's not only print name. I have to implement both print name and get weight. Okay? When I implement print name, it's going to give me the same error and still tell me you have to implement method, abstract method, get weight in animal. Okay, but I made it abstract, so I don't have to do that. Okay, so now we are in the class Husky, right? And in Husky, we're going to put this first, and then we call the super class method eat, right? So I'm going to say Husky eating. So after it prints Husky eating, it's going to call the superclass and access this method and print this method eat from the superclass. So this is like saying this, something like that, right? Right. So I'm going to put it the way it was before, super. So that's going to be our first method. Then we have to overwrite, we have to implement get weight, right? Because get weight is in the animal class and it's an abstract method. And we have to implement we have to override get tail 2, right? Get tail, which is here in the dog class. What was get in the dog class? But don't forget that Husky extends dog, so we can override this if you want to. So in this case, instead of saying super get length, we're going to return 20. Okay, so we're just overriding a method that is in the parent class, which is here, right? We're just overriding it. There we return 5. In the dog class, we return 5, but in the Husky, we return 20. Okay, overriding the method. Now I'm going to overwrite the void, the run method, right? That comes from the Carnivore Interface, right? Run interface, but the run interface extends walk, and walk has get speed, right? Okay, run method. Okay. One moment. Okay, that comes from the Carnivore Interface. Where is it? I'm losing visibility here. Carnivore Interface, probably because I have many. So this guy is the method that we are overriding there. And dog just implements this interface that has a run method, right? But as dog, we never implemented this method here because dog is abstract, right? But Husky is not abstract, so we have to implement this method. So we say Husky system.sys_out, right? And we say Husky is running at speed speed, or maybe miles per hour, right? And now we're going to finally implement the print name method. It has to be implemented because, I mean, if I don't implement this guy, I just comment it out, right? I still get this error because that is a method that has to be implemented from the animal class. Okay, it's an abstract method. So now that I uncomment it out, it doesn't have the arrow anymore. Okay, so now I can say sysout husky name equals get name. Okay? From the getter and the setters from the animal class, like it says here, get name. Okay, so that's the husky class. Okay, now let me create a rabbit class. As you can see, I have a lot of classes here, and they're all animals. They're animals. So now we're gonna say rabbit class. Well, rabbit extends animal and implements herbivore and hop. Okay. Right. So as it extends animal, the first thing that we have to do is just create the this guy. And of course, it works because animal has a constructor that doesn't take anything. Okay, where rabbit is gonna be okay. We say super, and then we say this. We're just calling the constructor of the parent class, right? And now we're gonna create another constructor, but this time it's gonna take the H, like the other ones. Okay. And then we say super, and we pass 3. Instead of passing the H variable, we just pass 3. Okay, we just pass an actual value. Okay. Now I'm going to override print details, right? And I'm gonna say, instead of saying super dot print details, I can say sysout rabbit average jump height is, and then we say that hop. You see, why are we doing this? Why are we doing this? Well, this is where static comes in, or comes into place. So when we have a static method, we go back to hop, this method is static, right? It's static. So static, what happens with static is that we don't have to instantiate an interface, right? We can simply use the interface name and use a dot, and it will give us visibility to all the static methods of that class. Okay, or all the methods of that class. So I simply use this, and then I can access my method from the hop interface by just using the interface name. That's the static thing that we saw before, but now we're seeing it again. Okay, let's continue. So now I have to implement get weight, right? And now we're gonna return to, right? Get weight comes from the animal class, right? Get weight, and we have to just implement it in any class that extends animal. Okay, and of course something is missing. And you guys tell me what is missing here. Why do we still get this error? Why? What are we missing here?
Print name.
Correct. So we have to implement print name, and then the error disappears. It's gone. Okay, so we're not gonna put anything here. Okay. Okay. So that's the rabbit class. Okay. So you guys understand what I did here with this static method?
It's actually pretty cool.
We saw it before, remember? When we have static method, we don't have to instantiate the class or the interface. We can simply access that method by putting the class name or the interface name dot, and then the method will show. Okay. Remember, the hop has a static method right here. Okay. So that's the rabbit class. Now we're gonna have a reptile class. As you can see, I have a bunch of classes here, and I don't know if I have space here. All right. So let me just Create class, red tie class. Okay. The red tie class doesn't extend anything. Okay. It has a protected Boolean method that returns a Boolean, right? And the name of the method has legs, right? And of course, it will return true. We just set it to true here. And it's going to have the double get weight, another method get weight, right? Which has nothing to do with the method from the animal class. Remember, get weight has nothing to do with this because red tie has no relationship whatsoever with animal. There's nothing here. We're not saying extends animal or anything, right? It just doesn't have any extension. It is not inheriting anything, right? So now it's just giving us a problem here. You just see this red line here, this red line. What does it mean? Why am I getting this red line here? Why? Can you guys tell me? Oh, it's telling you.
You have to return
Something.
something. You have to return a double.
So it says here, missing return statement, right? We have to return a double. So we're going to return 2, right? Double. Double.
2.0.
Yeah, 2.0, but double. An integer is promoted to a double. So a double will cover an integer. Okay. I can do this or keep it 2, but it's better to put 2.0 because it's more correct. Because a double is 2.0, not 2. Okay. So now let me create a snake class. Snake class. Sorry about that. Right? Snake class. Right? And the snake class will extend red tile. Right? Right? Now we're going to say, we're going to overwrite has legs, right? And we're going to return. If I leave it this way, what do you think it's going to return? If I leave it this way?
2.0.
No, this is a Boolean.
Oh, true.
True, because in red tile, it returns true, right? But I'm going to overwrite it, so I'm going to say false, right? I'm going to overwrite it. And of course, I can overwrite get weight as well. And in this case, it returns 2.0. Remember? 2.0. Now I'm going to say I want to return 10. Right? We just overwrote it. Okay. And I guess that's it for all the classes. Now let me get the main method. The main method here. Right? So I have a bunch of classes here. I have a lot of classes. I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes. 1, 2, 3, 4, 5, 6, 7, 8 interfaces. Wow, that's like 18 files here. Okay. Nice. Let me create the main method. Okay. So I'm going to say, yeah, why not here? So I'm going to create the main method here. Main class, not the main method, main class. And of course, the main class is going to have the main method. Otherwise, the program will not be able to run. Okay. Now, the first thing that we have to do is just come and instantiate Husky. Remember, the Husky is not an abstract class. Which one is the abstract class? What are the abstract classes that we have here? Remember? What are the abstract classes that we created?
You have dog.
Dog, right?
Dog and
Animal.
Animal. But Husky is not an abstract class. So I can instantiate Husky. I cannot instantiate dog. I cannot instantiate animal. If I do this, this will tell me that animals abstract cannot be instantiated. Okay? So if I have dog, right? I will get the same error. Dog is abstract, cannot be instantiated. But the Husky is not abstract. Okay, so I can easily instantiate Husky. And through Husky, even if I cannot instantiate dog and animal, through Husky, I have access to the methods in dog and the methods in animal. As simple as that. So I'm going to pass number 5, because remember that Husky, the constructor, one of the constructors in Husky has, well, the only constructor that we have has an age. So we have to pass a number, right? So now for Husky, now that I have the object, I can say Husky and set name. So something interesting. Husky doesn't have that method anywhere, set name. So what class has that method set name? What is
Animal.
Animal.
Oh.
So through Husky, I'm accessing animal, right? So because Husky is a descendant of animal, right? It's just the offspring of animal. It's like the grandchild, right? Because the parent, the father is dog, right? If you can see it that way. So basically, in programming language, you can say Husky is a dog and dog is an animal. Okay, that's why they descend from one another, and well, they descend one from the other and inherit all the methods and the properties of the parent class. Okay. So the name is Rex. We're just passing a name. Why? Because in animal, when you get the getter, the setter of name, you have to pass a string. So we're passing Rex, right? Now that we have the name, we can print the details, right? Now, if I run this guy, I get that animal, dog, Husky, Husky name equals Rex, and age, it's 5. Okay, we got all this. Why did we get this? Well, Husky will call the constructor from Husky, right? Right here. But as soon as you call the constructor, it will call the constructor in the parent class, which is dog, right? But dog will call the constructor of the parent class, which is animal. Then it starts printing animal here, right? It prints animal. Then it goes back to dog and prints dog, right? Then it goes back to Husky and prints Husky. You see Husky here, right? Now it goes to details, right? Details here. And then it says print name, Husky name, right? Print name. But print name is implemented in Husky, right? And it says Husky name right here. Husky name is Rex, right? So get name, you set the name in main, you set the name here. So now you're gonna get it, right? Using the get name. So you get the name and set Rex here. And the age, right, comes from this guy here that says system out age equals age. But what is the age? 5, because in the main class, we're passing 5. Okay? It's a little messy. It's like a spaghetti ball, but it makes sense once you understand it. It makes sense. Okay? Now, the next thing that we're going to do is just set the age to another number, another value. Okay? So we're going to make use of the set age method coming from the animal class right here, right? And we're going to pass number 6. That's what we say here, 6. Okay? And now we're going to print the details again. And we're going to get a different value. Okay? So we're going to get age equals 6. You still get the same name because we haven't changed the name. Now, if we had changed the name here, like Husky, set name, and say, for example, Jimmy, then we get 2 different values here, right? We get first Rex and then Jimmy, okay? But we're not doing this, okay? Now that we have the details, let's continue using the Husky object, and now we're gonna call the run method, right? And then we're gonna pass 10. So this run method comes from here, from Husky, right? We're passing number 10, and then it says Husky is running at 10 miles per hour. Okay, so if we run the main method now, we're gonna say that Husky is running at 10 miles per hour. Okay. Now we continue. We're gonna say sys out, and we're gonna say tail length equals, and then we say Husky that get tail length. So that's gonna come from Husky, this guy here, and of course it's going to return 20 because this is the return value that we have here. Okay, so let's do that and see what happened. We get 20 here. Okay, guys, what happens if I do this? Can you tell me? What do you think is going to happen there?
We're assigning get tail length to a new variable called tail length. And get tail length comes from Husky, I think, right?
Yes.
And it has a value. What's the value on Husky?
Right here.
20, okay. So it's 20. So tail length now is going to be equal to 20. So it uses out tail length.
Okay. So which
one? Compare,
yeah, which one?
Compare.
Yeah. Guys, which one do you think is more effective? The first approach or the second one?
Depends how you're going to use it.
If I want to use tail length again, throughout the program, which one do you think is more efficient? This approach or this approach?
If you're not going to change tail length, it's the same. Or we use the Husky.get tail length method.
Okay. Don't forget that every time that you call the method, you
have to go back to. Go ahead.
You're using resources every time that you call a method. Why not call it only once and then store the value in tail length and that's it?
Yep.
I used tail length before, tail length after that all the time. Because if you use this all the time, you're wasting resources. So it's better to use it only once, and that's it.
Use the method. Yeah.
So I use this value every time after that. No, I don't have to call the method again. Okay. So now.
And you declare tail length outside of the main. I mean, on top, in between the public class and the public spec, rather than down here. Yeah.
Yes, you could say int tail length, and like this, and then.
They're not the same.
No, because it's not the same name.
The L, it's yeah.
Okay.
There you go.
And
Yeah.
Oh, I have to make it static. Yeah, because you're calling it from a static context, right? So you can do it that way. Now it can be accessed from any. If I create a method here, and I say, for example, print void. No, it has to be outside the main method. It cannot be inside the method. Methods cannot overlap. So I have to say void print, and I can say print and say this out, tail length, right? And then I can call print from here, right? Of course, I have to make the method static, right? Now, if I do this, yes, it can be accessed from any method. And then we have here that it prints 20 because this variable became a global variable. Okay, it's just outside this method here. If you put it inside the main method, it is only accessible within that block, which is the block of the main method. But if you put it here, outside here, you make it a global variable, then it can be accessed from any part of the class.
You can really use this method of inheritance and using interfaces to create like a small database, if you will, where you have specific classes and interfaces that provide data back and forth, right?
Yes. Yeah. So I'm gonna make it like the way it was before, right? I'm gonna delete this guy, okay? And continue with this the way it was before. So now I'm gonna say sysout, the weight equals, and then husky get weight, get average weight, right? And that's gonna say that the weight is 30. Remember that I said in husky get weight 30, you see? But this is not the one that I'm calling. The one that I'm calling is the one from animal, which returns, that is implemented in husky. Okay, dog, get weight, get average weight is just returning a double. Okay, remember that this is 20, right? But what it returns is a double. It's going to be 30.0 because this one here is 10 from the animal class. This is 10 right here, right? And 10 plus 20, 10 plus 20 is going to be 30. But remember that you're returning a double, so it becomes 30.0. Okay. So now I'm going to create a class named bear. And then not create a class, create an object named bear. And then it's going to be created this way. Now the bear class is there, right? Now I'm going to say, but before I create that, I forgot to put something here. I can say husky.eat, right? And I can say sysout average husky get average weight. Right, that was already done. That was already done. Okay. So let me just print this eat here. And it says dog eating. And husky eating, animal eating, dog eating. Okay. When you call this eat method from here, where's husky? You get husky is eating, right? That is the first one that is printed. But after that, it called the superclass method eat, which is dog. So when it gets to dog, it first call the animal. So it prints animal eating, and then after that it calls it just prints dog eating, and you see dog eating here. Okay, it's just a chain of prints, right? Following the logic here, you understand that first the eat method from the parent class is printed first, and then this method is printed second, right? So now that we have the bear object, we're going to say bear set name and we're gonna say Jimmy, right? So in the class bear, here, we have that it stands animal, right? As bear stands animal, it has access to all the getters and setters from animal. That's why here we said set name Jimmy. Right? Okay, so now we're gonna say bear set age, just like it has access to set name, it has access to set age 10. Right? And now we can say bear dot eat meat, right? And bear dot eat plants, and bear dot print details. Okay? So let's print this. Let's see what we get here. So we get bear eating meat. It's right here. Bear eating plants. It's right here. And bear details, Smokey the bear. That is the name, Smokey the bear, right? And age is 10. So we go back to the animal. We say that the first element of the print name of the print details method is just the print name. But the print name, if you go back to the bear class, we have the print name is Smokey the bear. That's why we get Smokey the bear here. But the second part of the print details is the age. So the age is 10 because when we instantiate the class, we pass this 10 number here, which is the age. And then that particular method will get the age from here. So it gets age equals 10. Okay. Now we're going to create a class named rabbit. Remember that rabbit stands animal as well, okay? And implements herbivore and hop, right? So we can go back to main and say rabbit. We name the object exactly as a class. It doesn't matter, but lowercase. Say we new rabbit, right? And rabbit has one constructor that matches this one, right? Rabbit has one that doesn't have anything. It's this one here, okay? But as soon as you do that, you call it super class, which is animal. And animal doesn't have anything here in this method. It doesn't print anything, okay? So nothing will happen there, right? Now we're gonna say rabbit, and then we say eat plant, right? And rabbit print detail. Okay, so now let's see what happens. See what we get here. So eating plants, rabbit average jump height is 2. Okay, because we have in the rabbit this guy here, right? We just say eating plants because the animal class that has eating plants here. No, from the interface, from the Omnivore interface. That extends the Herbivore interface. And then the Herbivore interface says eating plants. Okay, so we get that from here. And then rabbit has a method that says rabbit average jump weight height is hop that average jump height, because the hop interface returns 2. Okay, that's why we have is 2 here, right? It's a little confusing, but I mean, guys, if you just analyze it for just a few minutes, you will understand it. Okay. Now, can I do this? Of course I can do that. But now it says that it's ignore. Why? Because this returns something. Get average returns something, right? It returns 2. So how can I solve this, guys? How can I solve this problem that I have here? How can I solve it? There are two different approaches.
Int equal jump height.
Right? What are we returning? An integer, right? So good. So we say,
Int.
we can say int
Jump height.
Equals.
And then hop dot get average jump height.
Okay, that's one approach. And what is the other one? Of course, I have to print it, right?
Yep.
Okay, so that's fine. That's one approach. What is the other one? Well, the other one is simply, print the method call. That's it. Right? The same thing. This here is the same as this, right? You're just storing this in a variable. Okay. Now, if we get that, we get 2 and 2.
The same.
Okay. We can simply make it a little more, more meaningful here, right? Right. And then we can do the same here. This way. Right? Same thing. Okay, perfect. Okay, so we're not saying this. Okay, hop is abstract, right? Take a look at hop here. It's an interface. Interfaces are by default abstract. Okay, so we cannot do that. So we can simply access the interface using the interface name, because this get average jump height is a static method. So now we're going to create another object from the cat class. Okay. And we're going to pass 3, which is the age, right? And we say in speed equals cat that gets speed, right? And we can say this is out. Cat speed is speed, right? Miles per hour. Okay. Okay. So cat speed is 5 miles per hour. Guys, I can also say cat print details, right? Yeah. But we don't get anything here. It's just animal. Why? Because animal is the name that we get from here, right? Right here. All right. So what we can do here is set the name to Misu or Meow, whatever you want to say. Cat, set name, and then Misu. Right? And then we get something here, something different. Okay. Of course. And then we have to cat set name. Misu, cat print details. just to get animal. Yeah, because we're calling this guy here from animal. Okay. Yeah, we didn't implement the print name here in the cat class. Where's the cat class? We don't have anything here in the, so we could say this is out, name equals get name. Okay. So now if I print this, I should get something. Name Misu. Okay. We didn't implement anything in the print name. Right. Guys, how can I solve this? How can I print this in a different way? How can I print this in a different way?
Just sys out and print the message without integer
Correct.
speed equals cat.
So I can say, I just copy this, right? And instead of saying speed, I can say cat dot cat speed. Right? And then I get the same text 2 times. Right? So there's different ways to do it. And like I said before, this is more efficient than printing it directly from the sysout thing. Okay, guys, I think it's time for a break, right? It's 6:44.
Yes.
How about that? You think it's a good idea? Take a break?
That's a perfect idea. Yes, thank you.
It is.
All right, guys. So I see you in 10 minutes. Okay, guys. So now I'm going to create another package, and I'm going to name it polymorphism. Okay, we're going to see polymorphism today. Now, what is polymorphism? Well, like the word says it, multi-forms. Okay, that the objects, methods, variables can take different forms. Okay. Right. So here it says, for example, here, polymorphism means many forms. And it occurs when we have many classes that are related to each other by inheritance. Like we specified in the previous chapter, inheritance lets us inherit attributes and methods from another class. Polymorphism uses those methods to perform different tasks. This allows us to perform a single action in different ways. For example, think of a superclass called animal that has a method called animal sound. Subclasses of animals could be pigs, cats, dogs, birds. And they also have their own implementation of an animal sound. The pig oinks, the cat meows, etc. So we have an example here. This is the class animal, right? That has this method that returns nothing. And then it has this print, animal makes a sound. Then the class pig extends animal. So you can have the same method here and then do this. So this is telling me something. This is something that we already know. And guys, what is this? Can you tell me what this is? What are we doing with this method here? What are we doing? It's the same method, right? The same name. What are we doing with the method?
Is it overriding?
Overriding, right? So one of the ways to implement polymorphism is overriding and overloading. Okay, so we already implemented polymorphism in our classes before, but we were not fully aware that we were using polymorphism when we were doing overloading and overriding. Okay, so basically what we do here is overriding the method from the parent class, right? This parent class says the animal makes a sound, and here the pig says we see, we, and the dog says bow, 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 wow. All right. Same here. Now we can create a pig and a dog objects and call the animal sound. So like this, you have the animal class here that have this animal sound method. Then the pig stands animal. Now you have the same method but override. Same here. And in the main class, you can create an animal object, right? And then you can create an object, right? A pig object using the animal class. Why? Because pig stands animal, right? So we are using the animal class to create a pig object. So basically we're creating a reference here of the pig object that refers to the class animal. So this is another way to create objects in Java, right? By simply extending the class animal, in this case, and creating an object from the class using the class animal, like it says here. All right. So let's try to do this in our program and see how it works. Okay. So let me go back here, right? But the problem that we have here is that the class animal is abstract. So I cannot create an object from the animal class. But let me create here an animal class, right? This is the animal class from, and let me have here, let's say, public, and we can say, right, poly void, make sound. And then we can say, this out, the dog barks. Okay, no. Animal makes sounds, right? Animal makes sounds. Right. So now we can create a dog class, right? A dog class that extends animal, right? And then we can override the method, right? Make sound, we override it, and we say, this out, dog barks, right? Right? And then we can create a cat class, I'm sorry. And this is cat. Okay. And then we can say, make sound, extends animal. And then we can say, make sound, say cat, right? Now if you have a main class, and then in the main, I declare my method, and then I can say animal is new animal, right? So that's an object for animal. Or I can say animal dog equals new dog. So that's possible too, right? Now if I say dog, make sound, let's see what happens. Right. Dog barks. You see, just because dog extends animal, I can use this guy here. Okay. Right. Now, I can also say animal, cat, new cat. Right. And then I can say cat, make sound. Right. Then if I print that, I get exactly the same thing, right? And then cat meows. Okay. So here, right, we can call the animal sound, in our case, the make sound method on both of them. Okay. When and why and when to use inheritance and polymorphism? Well, it is useful for code reusability. Reuse attributes and methods of an existing class when you create a new class. We're just reusing the methods from the existing class from the animal class. I can simply say animal, make sound, and get that method as well from the animal class. And it says animal make sounds. Okay, so that's one way. That's one way that we can do that. Okay, so this is just an example. This is not what I want to create here. Okay, so I want to come to the animal class, right, and take a look at my other animal class to see if it's the same. Okay, see here, getters and setters, system out age, and then get weight. So I'm going to use the same guy for my animal class. What I just did was just an example, okay? So I'm gonna close this guy and I'm going to do this, okay? And of course, I have to make it abstract, okay? Okay, that's it, just like the first one, okay? Now I'm gonna have a bear class. Let me go to the bear class. Okay, where is it? Step method. The bear class. Let's take a look at the bear class to see if it's the same. All right, take a look at it. Yes, it's the same. Right, copy. And then I'm gonna create a bear class here. Okay. Right. Now bear extends animal. And implements omnivore. Okay. So let me go to omnivore here and take a look at omnivore. So omnivore is the same guy that I need for my class. So I'm gonna copy this guy. Actually, I'm gonna copy this guy, close the omnivore and create an omnivore here. Okay. Omnivore. Okay, and the omnivore extend these guys here, right? And now I have to create a carnivore and a carnivore interface, right? Carnivore interface. I'm gonna use the same classes, guys. That's why I'm doing this. Carnivore interface. And I have here this guy, right? Omnivore still needs to have the omnivore, the herbivore interface. So the herbivore interface, I have to create it here. Herbivore. Okay, so the herbivore interface has this guy. Okay, perfect. So now I have this guy: animal, bear, omnivore, herbivore, and carnivore. Perfect. Now I'm gonna work on bird. I have the bird guy, right? Bird has the same thing. I don't have to change anything. So just call the bird class, and the bird class doesn't extend anything, okay? Any class, okay? Now I'm going to have a can run interface, okay? So I'm gonna create an interface here. And the interface is going to be called can run, just like the other one, right? Can run. Then the can run is going to have this method. Okay, perfect. So now I'm going to have the cat class. It's right here, and I have to change it. And then cat is going to have the same guys that it had before. So I'm going to create this guy here, right? And then have these guys here. Okay, perfect. Okay, that's the cat class. The dog class is going to have the same guys as before. So I'm going to open the dog class here. I'm going to delete this guy and copy these guys from before. But this guy stands animal and implements has tail and can run. Okay, So let me create the Hashtail interface. Right? Right? And then Hashtail, we have this guy here. Okay. Right. And then dog will need to implement or make it abstract. Okay. So dog is fixed, right? Okay. So now we need to continue here. Dog class, ego class. So the ego class has the same method as before. Okay. Ego class, right? Ego class extends bird, right? And it has this method here that I had before. Okay. Now we have the hop interface. So the hop interface is going to have the same static method. Right? And the hop interface doesn't extend any other interface. So it's going to have this guy, right? Now we're going to have the husky class, which is going to have the same methods as before. Okay, nothing new. So husky will extend dog. Okay, so I'm going to have husky here. Husky extends dog. Right, and then I have just copy what I had before. Right. That's it. Okay, so I have the husky guy here. Now I'm gonna have the rabbit just as I did before. So let me create the rabbit class from here. Let me take it from here. Okay. We're gonna have exactly the same thing as before. So I can close this rabbit, create a rabbit class here. And rabbit extends animal and implements herbivore and hop. Okay. So now I'm gonna do this and rabbit is done. Right? Just the same thing as before. I'm gonna have reptile. And reptile, we have the same thing as before. Okay. Reptile. Okay. So reptile have this guy. Right? And then we have an interface named run. Just like we did before. And then it extends walk, just like we did before. So now we have to create an interface named walk, right? And then walk is gonna have this method here, right? Now we have the class snake, and snake extends reptile. We're getting to the good part here. Okay, just reproducing what we saw before. Snake extends reptile. Right. And I just did that. And that's it. That's it. Now I have to create the main class here, which is already created. It's right here, right? and then I'll just delete all this guys, right? So in the main class, I'm going to have exactly the same as the other main class. Okay, so I'm going to bring the main class from here, and I'm going to have the same as the other main class. Okay, right? We would just want to separate one from the other. That's why we're doing this, right? So if I print this guy, I just get the same information as before, nothing new. Okay, perfect. Now we're going to have a class named Polymorphism. And this is when we're going to see this guy. Okay, so this class is going to be called Polymorphisms. Okay. So the first thing that we're going to do with this class is just create the main method. Okay. Now that we have the main method here, we have Husky, which is a class that we have before, we created, and we say new Husky. 5. Okay, that's the age. Don't forget that. Okay. Okay. Good. So now we say Husky, and the first thing we're going to do is give it a name. Okay, and we always use Rex. Okay. So now we can do this. Dog equals Husky. So that's something that we can do, right? And this is just another reference to the Husky object in memory. We have one reference here, and then we have another reference. We just assigning Husky to dog, right? So why can we do this? Because Husky is a dog. Don't forget that Husky stands dog. So Husky is a dog. So that's why we can do that. We cannot do this with this. I mean, that's going to be a problem, right? We require cat and we provided Husky. So we are just assigning a dog to a cat. That doesn't make sense. Okay? It's like mixing two breeds, right? You don't do that. So you have to have a dog here because Husky is a dog. Okay? So now, if we say dog, print details, let's see what we get here. Okay. It says that this is redundant because we don't need to use this, but let's use it. Let's see what we get. So we get Husky right here. Okay, so we're just making another reference to Husky object, to the Husky object in memory. You see, guys, this is another way of polymorphism because we're using this Husky here and it has a different form now. It has a dog form. But still, when you print this, what you get it is Husky. Just like you will get here. Same thing. Okay? You get the same thing here. You see? So this dog doesn't make any difference. It's just another reference to that Husky object. Okay? So that's one way. Okay? Now we can have Hastail, which is the interface, right? And we can say Hastail equals Husky. Why can we do this? Because Husky refers to dog, but dog, there's dog, implements Hastail. Okay, so we can use the interface here and create an object of that interface, right? And assign Husky. Because Husky stands dog and dog implements Hastail. Okay, so now we can say sys out. We can say tail length hostile dot get length, get tail length. Okay, so now I can do this and get tail length 20. It's like saying this: husky get tail length, and of course this will be ignored, right? We print this. That's fine. So now I can do this, and then we get tail length 20. But here, you see get length here from husky. It returns this, so I have to put it in a method. Right here. Same thing. You see, I can do that with husky. I can do that with hastail. This is polymorphism. So we just using many forms of that object. Okay. First, we assign the object to a dog object, right? Remember the husky extends dog. And second, we assign husky to an object of that interface, right? Of type interface, because remember that husky extends dog and dog implements hastail. I cannot do this with another interface that dog doesn't, with this one, for example. I cannot do it with walk because husky or dog, they don't extend or implement walk. Walk is implemented by, I think it's a cat. Let me see here. No, cat is the one that implements, let me see here. Oh, so run implements walk. And then see rabbit. Rabbit implements hop. And dog is implement can run. And bear implements omnivore, animal, husky, dog, reptile. Reptile doesn't implement that, that's for sure. And think walk. So what is the other that implements walk? So this is a mistake, very, very big mistake. So run implements walk, okay? And walk has this, that's what this walk thing, okay? So this is not a reference to husky because husky, none of them do that with walk, okay? So that's one way. So this is another reference to husky. Okay. Okay. So now we can say can run. That's another interface, right? Okay. Can run. What's going on here? Oh, I created this polymorphism in the wrong guy. Okay, this is where it goes. Okay. Okay. So I can say can run, and then can run equals husky. I can do that too, because dog implements can run. Okay, so I can do that too. Okay, so this is another reference to husky object in memory. Okay. Okay. Now if I say can run, that run, and then we say 5, then we can just run that, and we get husky running at speed number 5 equals 5. Okay. Now we can say animal, just like we saw before, animal equals husky, right? And that's simply another reference because we are assigning a dog to an animal, and dog is an animal because dog stands animal, right? So here we have another reference, and we say animal print details, right? So now if we print this, we get husky name Rex and age equals 5. That's what we have in the animal class right here, right? Print name of this. Okay. Now we can do another one. So this is another reference. We have this, and we say object equals object husky. And that works too, because remember, the husky is an object, right, of the class husky, but husky stands dog, right? And dog stands animal. And animal stands what class? What class does animal stand? Guys, you here? Guys, what animal that class stand? Or what class does animal stand? Guys, can you hear me? Well, the class object of the class dog stands animal, and animal stands object. Okay, so we can say object right. So this is simply another reference to the class, the object, husky object in memory. Okay, so now we can say husky my dog, right, equals animal. Okay, and this is another reference, but now we have a problem because this is upcasting. So we are providing an animal, but we require a husky. Okay, so this is another reference, right? But for this to work, we have to cast it. We say husky, and then it works, right? We have to cast it because here we're going from the higher class to the lower class, but here is the opposite. We're going from the higher class to the lowest. Okay, so in this case, we have to cast it. Okay, we have to cast animal to husky because animal is animal. It's not husky. Husky is an animal, but animal is not husky. Okay, so we have to cast it here. Okay, So now we can say my dog print name, right? And here we get this husky name equals Rex. Okay. From the husky class, take a look at here. Husky name equals Rex. Okay. So now we can say animal cat equals new cat, just like we said before, and we pass the age. Okay, just like the example that we saw before, right here, the animal, and then the name of the object, and then the class that you're instantiating the object from. So in this case is cat. Okay, so now we can say cat and print something like maybe print details. See what it prints now. And then we get animal age 2. Okay, that's fine. Another thing that we can do here is just create a cat, right? My cat equals cat. Okay, we have a problem here because this cat is an animal. So the same that is happening here is exactly the same thing. This cat is an animal. So what we have to do is just cast it. Okay, and then it works, right? Then it works. So that's the way you do it, because remember, we're just upcasting. Okay, so this is called upcasting, right? We're just moving from the bigger one, which is the animal, assigning to a smallest one. Okay. I put here another reference to cat, right? To cat object in memory. Okay. So we can also have a bird class. Bird class, and so equals new bird, right? And then we can say object, bird object equals bird. So this works because bird is here, and bird extends the class object. So this is like just doing this. Okay, similar. Okay, but it's unnecessary. If you hover over this, it says class bird explicitly extends Java object. So this is not necessary. Okay? This is already there, right? That's why we can say object bird object equals bird, because bird is an object. Okay, or bird stands the object, the class object. Okay, that's why you can do that. We also have the class eagle. Just create an object from the class eagle equals new eagle, right? And we can say bird, eagle bird equals eagle. Okay, this makes sense because remember that eagle extends bird. So this one can be assigned to bird. Okay, and you don't have any kind of casting or anything. It's just like this one. Similar. Okay, similar. Right? Also, you can do this object, eagle object equals eagle. Because don't forget that the class eagle stands bird, and bird stands object. So that's possible too. Okay. Now we can do this. A list of strings. We saw that before, right? Name a list, and then we say new array list. And we can say animal rabbit animal equals new rabbit. Right? And we can say rabbit animal print details. And then if we run this, we get rabbit average jump height is 2. Okay, so we can do that, right? We can do that as well with rabbit. Remember that rabbit stands animal. Okay, rabbit stands animal. Okay. So you guys understood this a little bit? How it works? So whenever you stand something, whenever you stand dog or stand animal, you can use those, that class that you stand to create an object of your class. So you can say this animal bear equals new bear. Simply because bear stands animal, right? Bear stands animal, and bear implements omnivore. So we can do this as well. We can say omnivore, right? Right? Yeah, we can say it works the same. Why? Because bear is implementing omnivore. Okay, bear stands animal and bear implements omnivore. So we say omnivore, right? Dot eat meat, right? And that's going to print what we have here, bear, that says eat meat, and say bear eating meat. So let's print it. Let's see what we get. Bear eating meat. Same thing if we do bear eating plants. So this one is eat. This is different because we're going from the bear class to the animal class. So animal doesn't have eating plants, or, you see, animal doesn't have eating plants or eating meat. Animal has eat. It's here. Okay, so now we can print eat, and then we get animal is eating right here. Okay, you can also do this. Bear 2 equals new bear. Okay, animal bear 3. Can we do this? Bear 2? Yeah, that's possible too. Okay. The problem is when you have this guy is that you do bear, right? Bear is an animal, right? But what if I do this, right? I create this bear, or maybe bear 3, yes, equals new animal, right? Right? It cannot be extracted. Okay. So maybe I can say new bear. Okay. That's fine. Now, what if I do this now? Bear 3, or bear 4, sorry, equals bear 3. Right? This would not work because we are assigning an animal to a bear. Actually, it's a bear to an animal because a bear is an animal. An animal is not a bear. A bear is an animal. So what we have to do here is just cast it to a bear. And then you solve the problem. Okay. So you're making the bear a bear, right? That's why you do this. Or actually, you're making the animal a bear because this bear 3 is an animal. Okay. Remember, the child is the father, but the father is not the child. That's the way that you can understand that, right? If you have an animal class, you have a cat class, the cat is an animal, but an animal is not a cat. An animal can be anything, but a cat is an animal for sure, okay? That's why here you have an animal, right, which is bear 3, and you create an object of the class bear, but then you want to assign an animal to a bear. No, you can assign a bear to an animal, right? So this is possible, right? This is possible. You see? Because a bear is an animal. You see? A bear is an animal. What you cannot do is what it was before and do this. Because an animal is not a bear, right? An animal can be a bear, can be a dog, can be a cat, can be a rabbit. So you have to make it a bear for that to work. So you have to cast it. Okay? So this is casting, right? I don't know, guys, if you understand what I'm saying here. Okay? So this is called upcasting, right? This is upcasting. This is upcasting, right? And this is called downcasting. Okay? Downcasting. Because you're going from down, you're going from animal to bear. So you're going down. So you're casting down. Here you're casting up because you're going from a bear, you're making from a bear, from an animal, you're making a bear. So you're upcasting. And here from a bear, so you're making an animal a bear. So you are downcasting. It's a little, the way it's explained is a little confusing, but basically you're going from up down because bear implements omnivore. So you're going from down, you're going from the highest to the lowest. That's why it's called upcasting. Or maybe you can see it from the right side to the left. So you're going from the lowest going up. So basically you're doing this, right? Lower, upper, okay? That's why you have bear, which is bear implements omnivore. So bear inherits from omnivore. So you're going from the lower, okay, let me put it here, from the lower to the upper, okay? And here, you're going from upper to lower. So this is here. Remember that this bear is an animal, right? So you're going from the upper to the lower. That's why it's downcasting. And this is downcasting. And this is upcasting. Right? Upcasting. Okay. So this is upcasting 2. And this is upcasting 2. This is upcasting. And this is downcasting. Right? This one is upcasting. This is upcasting. This is upcasting. This is upcasting. This is upcasting. And this is upcasting. Okay. When you downcast, you're gonna get access to the lowest object details. Okay, and when you upcast, you will get access to the one that is put in the first place. Okay, so this bear will have access to all the omnivore. Okay, so if I print this, I get that bear eating meat. Okay, from here. Nice. Okay. So this is all upcasting, downcasting, polymorphism. Okay. So you guys here? Guys, you here?
Yes.
Oh, see,